Hello everyone, this is Tiger again. So today we will talk about the first half of the paper from 2017, and that's the JMC paper. So let's get started with the first question. This is a really simple numbers and operations problem. And of course, it's just about the four basic operations. So essentially, this is just a calculation question. 2 take away 1, that's 1. 2 divided by 1, that's 2. 2 times 1, that's 2. 1 times 2, that's also 2. 2 adding 1, that's 3. So the largest one, of course, is going to be E. I don't expect anyone getting this wrong, right? And the second question, it is a word problem. And it is a word problem on time calculation. So it says that the cake should be baked for 1 hour and 35 minutes, and she puts the cake in the oven at 11:40 a.m. So if I do 11:40, adding 1 hour and 35 minutes, it's going to be 12:75. But we know that an hour doesn't have 75 minutes, right? It has only got 60, so we need to convert 60 minutes into an hour. So we've got 13 o'clock and 15 minutes there, which means that it is equal to 1:15 p.m. So that's how we get it. That's how we get it. All right. And then let's take a look at the next question. Just give me 1 second. Sorry about that. All right. So the third question, it's going to be geometry on the transversal of parallel lines. Okay, so what is the value of x there? First of all, we know that for parallel lines, the alternating angles are going to be the same. All right, so it means that x is equal to y. And now we know that y adding 303 is going to be 360 degrees. Which means that x adding 303 is also equal to 360 degrees, right? That's what we can do, a substitution there. And 360 comes from the sum of all angles at a point, okay? So we can calculate that x is equal to 360, take away 303, so that's going to be 57. So the answer is going to be D. Okay. And then question 4, it is another word problem, and it's about the percentages or fractions, all right, or the conversion between them. It says that a download is 95% complete, which means that the incomplete rate is 1, which is 1 whole, take away 95%, and that gives us 5%. And 5% would be equal to 5 over 100. And if you simplify it by dividing 5, you get 1 over 20. So it means that the answer is going to be E. That's the fraction that is yet to be downloaded. All right. As for question number 5, this is some fast calculation techniques in multiplication. So it's on numbers and operations. And again, it's about the 4 basic operations. So 201 times 7, take away 7 times 102. That's going to be equal to 7 times 201, take away 102 in brackets. That's the, like distributive law applied in the inverse direction, applied the other way around. So we have 7 times 99, which is 7 times 100. Take away 7. And that is going to be 700 take away 7, which is 693. So we have the answer C right there. Okay. And as for question 6, this is a miscellany question on magic squares. Magic squares. All right. So we know that the center number of a magic square is equal to a third the sum on a line. So it means that it is equal to 1/2 of the two numbers on the on both sides of it. So we can see that 10 adding 2 is 12, 8 adding 4 is 12, 5 adding 7 is 12. So whichever pair you take, the center number is going to be 12 divided by 2, which is 6. And now, of course, I will be able to calculate the sum in each line, right? That's going to be 18. So it means that the sum in every line is going to be 18, which means that this is 9, this is 3. So that's how we get the answer D, okay? As long as you can figure out the center number, the rest of the question is just basically calculation. So it's going to be rolling out for you. And question 7 might be a little bit clumsy if you don't have any specific tricks to solve this question, because it's about comparing fractions. So it belongs to the numbers and operations. And it will be comparing fractions. So first of all, we can try to get the values of each of these numbers. The first one is going to be 22 over 15. The second one is going to be 8 over 15. The third one is going to be 11 over 4. The fourth one is going to be 5 over 6. And then the last one is 15 over 8. All right. And now if I look at these 5 numbers and I want to find the middle one, first of all, we can just try to estimate how big they are, right? So we can see that 22 over 15 is in between 1 and 2. This is definitely smaller than 1 and greater than 0. 11 over 4 is greater than 2 and smaller than 3, right? Smaller than 3. And this is, of course, smaller than 1. And finally, the last one, between 1 and 2. Right. So it means that C cannot be the answer. That's going to be the largest one. And B and D cannot be the answers because they are going to be the smallest two. So if I want to find the middle one, it means that it's going to be the smaller one of the remaining two, right? So now I'm comparing 22 over 15 to 15 over 8. And we can see that 22 over 15 is 1 and 7 over 15. 15 over 8 is 1 and 7 over 8, which means definitely 1 and 7 over 15 is smaller. So we've got the answer A. Okay, so that's how we can figure out the answer for this question. As for number 8, all right, so I'm putting my head here this time. So this is a very typical half area model in geometry. So it belongs to the half area model. Basically, well, you can see that triangle QTR is half of rectangle PQRS, because if you are just doing a little bit of a line there, this section is equal to this section is equal to this section, right? We are essentially just taking the diagonals of two rectangles right there. Or the other way you can think about it is that this triangle QTR has base as the length of the rectangle and the height just as the height of the rectangle, or the width of the rectangle. And we know that for triangles, the area has to be divided by 2, right? So that's why it is half of the rectangle. So now we just need to calculate the area of triangle QTR, and that's going to be 2 times 4 divided by 2, which is 4 square centimeters. And the area of PQRS is going to be 2 times of that. So that's going to be 8 square centimeters. All right, so that's the half area model question. And as for question 9, this one is even simpler. I would say this is just a numbers and operations question. Well, of course, if you want to say that is a word problem, that's fine. But essentially what it's doing is just some decimal calculation. So it says that he will divide a minute into 1,000 parts. A minute has 60 seconds. Divided by 1,000, that's equal to 0.06. You just move the digit 1 from there 1, 2, 3 times. And there you go, right? So that's how we can do it. And the answer is going to be D. Well, there's not much to explain with this one. Yeah, just like that. And question number 10. So we are just trying to see which of these integers is not a multiple of 45. So for these kinds of questions, of course, it belongs to the number theory. And that is going to be about divisibility, right? So to be a multiple of 45, it needs to be a multiple of 5 and a multiple of 9. So all of them must be multiples of 5 because they are all ending with a 5. So we just need to see which of them is not divisible by 9. 7 adding 6 adding 5, that's adding up to 18. 6 adding 7 adding 5, that's 18. 5 adding 8 adding 5, that's 18. 495, that's 18. So finally 305, that's 8. 8 is the only sum of digits that is not divisible by 9, right? So it means that the whole number is not divisible by 9, which makes it impossible to be a multiple of 45. Okay, so that's it for this question. Next we have question 11. So this is a pretty smart one. I would say that it's about the exterior angles in geometry. Interior and exterior angles. So the first way we can think about this question is using your spatial imagination, which is when you imagine that this heptagon is really tiny. It means that all the squares around it, they has to be really tiny as well. Then what happens to these angles? So they're going to shrink, they're going to shrink, they're going to shrink until all of them forms a circle, right? Because all these squares on the outside, they have been rotating a full turn. They're connecting to each other, yeah? So that's why it is 360 degrees. But then, that might be a little bit abstract. So if you want to do it the geometric way, of course, that's all right. We can see that at each vertex of this heptagon, at each vertex of this heptagon, there will be 2 right angles, the interior angle, and the marked angle, right? And it adds up to 360 degrees. So 2 of the right angles. Which means that the interior angle, adding the marked angle, is 360 degrees. Take away the 2 90s, so that's going to be 180 degrees. Now, if I'm removing the interior angle from 180 degrees, what I have left is just the exterior angle, right? So it means that the marked angle at each vertex will be equal to the exterior angle of the heptagon for that corresponding vertex or the corresponding interior angle. So for all 7 of them, if I want to find the sum of marked angles, it's equal to the sum of exterior angles of a polygon. And we know that the sum of exterior angles for a polygon has to always add up to 360 degrees. For the same reason, basically. Because if I want the whole shape to join up, it's going to turn a full turn, right? So the angle that they're turning through is going to be the exterior angles. So that's where the 360 comes from. So essentially, that's just going to be the answer. Okay, so that's for question 11. And for question 12, a very classic word problem on ratios and proportions. So the ratio is 315 to 600. So 600 represents the total, 315 represents the girls, and it says that the proportion is the same when the number of pupils increased. So what is that proportion if I want to simplify it? So we just divide both sides by 15, and we get 21 to 40. And now how many times, so that's dividing 15 on both sides, and how many times is 640 that of 40? That's 16 times. So we multiply 16 to get 640, and 21 multiplying 16, that's going to be 336. So the answer is D, 336. Of course, the other way you can do is to divide 315 by 600 and then multiplying it by 640. That's also fine. For question number 13, so this might be a little bit, kind of requires a very strong understanding of the basic concepts, and you cannot fall into the traps given by the question. All right, so this is a numbers and operations question again. And it is on indices and surds. So first of all, doubling a positive number always makes it larger. That's going to be right, because that's going to double the length of that number on the number line, right? So of course, it's going to make the distance away from 0 a little bit further. So that's going to make it larger. And squaring a positive number doesn't necessarily do the job. If I am squaring a positive number that is greater than 1, it makes it larger. But if I'm squaring a positive number smaller than 1, for example, like 0.1, when 0.1 is multiplying itself, it becomes 0.01, which doesn't really make it larger. And of course, the third one is just like the second one. Taking the positive square root is going to make it smaller. Just use the same example. What if you take the root of 0.01? That's going to be 0.1, which is greater than 0.01. So these two are false. Only the first one is going to be true. Okay, so that's it for this question. And then for question number 14, this is a geometry question on reflectional symmetry. So what do we do for this question? Essentially, it says that this grid needs to have 2 lines of reflection and symmetry, right? But, well, when nothing is filled, it already has 2 lines of reflection and symmetry. And no matter what I try to fill in, it must abide to these 2 lines of reflection or symmetry, because if the shape looks the same, that's the maximum number of reflection or symmetry you can have. All right, like filling in some grid boxes is gonna make it less. So like it can make it less, or it can make it the same, but it can't make it more. Like there can't be more lines of symmetry when you're shading in some squares. So we can just try to draw the 2 lines of symmetry out. And we can see that that is cutting this rectangular grid into 4 sections, right? And basically for reflection or symmetry, and if there are 2 lines of reflection or symmetry, I just need to know what happens in one of the zones or one of the regions. And that's going to happen to all the 3 other regions. Now it says that I'm shading in 4 of the small squares, which means that I need to shade in 1 square in one of the regions. So we can see that the region has 2 squares and 2 half squares, right? So of course I can shade any one of the 2 squares. If I'm shading 1, then I will be shading all 4 of these, right? If I'm shading 2, I'll be shading all 4 of these. But what about the 2 half squares? So these 2 half squares, they add up to 1 square altogether. And if I'm doing that, I will be shading in that 4 parts as well to make 4 squares altogether. So there are just 3 ways for me to shade an area of 1 square in any of these 4 zones, separated by the 2 lines of symmetry. So we know that the answer is going to be 3. All right, there can't be more than that. Okay, so for the last question, this one is kind of simple, as long as you have learned a little bit about indices and surds before. So again, this is about indices and surds. Don't know why in this year's paper there's so many of these kinds of questions. So first of all, we need to realize that 49 is 7 squared. And then it becomes really simple. When we are dividing the square 49 by the square root of 49, we are dividing 7 squared by root 7 squared, which means that I have 7 to the power 4 divided by 7, and that is going to be 7 to the power 3, which means it is a whole number, so there is no remainder. The remainder is 0. Okay, so that's all the questions for the first half of this paper 2017. I hope you get what I'm saying, and if you don't, just let me know. Leave your message in the chat and I'll try my best to help. All right? So, see you all on Thursday again. Bye-bye.